Good morning, everybody. Today we're going to learn about format, color mode, and resolution. So these are the basic building blocks of the digital world, and they also influence everything from print media all the way to the web and video and just about everything that you're going to be learning while you're in communications. What we're going to do is we're going to be able at the end of this section to choose the correct format, the correct color mode, and the correct resolution for what your end product is going to be. For example, if you're going to do a high-end magazine like The Agriculturalist, then you need to know what of these three things that you need to set it at. And high-end projects include things that are going to go to a commercial printer and advertisements and that sort of thing. We're also going to learn about desktop printing, what those requirements are. And a desktop printing means if you're printing on the printer that you have in your office, and that's going to be the end product. That's what desktop printing is. And that resolution and color mode and everything is completely different than what you do for high-end printing. And finally, we're going to learn what digital projects, what those resolutions and color modes need to be. And another thing we're going to learn today is the difference between RGB, red, green, and blue, and CMYK, cyan, magenta, yellow, and black. So we are going to know how to learn, we are going to know how to change those color modes in Photoshop. And we're also going to know how to say the correct format at the end of your project for what the end use is of it. We're also going to touch on PMS, which is Pantone Matching System, and when it's the appropriate time to use that. And we're going to touch on hex colors, which is only for web design, but we're just going to be familiar with that. That's not really our main focus in this class. So the first thing I want to do is I want to give all of you some handouts. The first one is going to be a list of definitions. This is something that you're going to have to know from now on. I mean, if you get into a marketing situation where you're the only person in the office and they say, hey, we need to send an ad to so-and-so magazine, these definitions will help you know what you need to do. And it will help you know how to talk to a printer or a full-time designer if you should be using that. So, I'm going to hand out these. And also, very, very important, this is a chart that tells us what format, mode, resolution is needed for four different situations. The designer, which is going to be you in this class, the high-end print, desktop printing, and online projects. Now, right now this is blank, but by the end of this section, all of you are going to be able to fill this out correctly. And please know that this is very important because you will be tested on this chart itself. And the reason that I'm emphasizing it so much is because that is the very basics of graphic communication. If you don't know the answers to those things, your projects are never going to be exactly what you want them. And many of you will end up in places where the marketing department consists of one person and maybe an intern. So knowing these things will help you. You'll have a leg up in the industry by knowing these things. Okay, I will get off my soapbox about that. So, the first thing that we're going to do is talk about color. And when I mean color, I'm talking about the different kinds of color that you use in the digital world. And the definitions, we will go through those as we go through. And color is really simple. I mean, we've been coloring since we could hold a crayon. You know, things are like apples are red, grass is green, and the sky is blue. But it's not really that easy. So let's go on to the next thing. I was getting ahead of myself. Color for designers. Color management. Now that sounds really funny, doesn't it? Managing color. Color can take care of itself, right? Not at all. Believe it or not, in the printing industry, there is an entire industry that is just taking care of color, calibration of the monitors, calibration of digital printers, and color profiles, which is basically calibration for high-end presses. We will be taking a tour of a high-end press situation, a commercial printer, and you will see what I mean by the high-end presses. It's not something that's like a copier that sits on the end of your desk. It is something that would not fit in this room. And every color has its own particular tower. So it's very important that they get those things right, because it's very expensive to keep testing. So the first thing I want to talk about is how printing used to be done. This right here is not a very good example of color management. Honestly, it's really washed out and not very true and all that kind of stuff. But this is how color used to be, and people were okay with it. You know, things were not natural, but it was all right because they were doing the best they could then. But with technology, now we can control things much more. The first mode that I want to talk about is RGB. It's the one that when you're looking at a screen, you're looking at your TV, you're looking at your iPad, your phone, all of those digital things, that is the color mode that those particular items use. It's for on-screen, it's for anything, it's projection, it's everything. CMYK, however, is for printing. It's for when you put ink on paper. That's where CMYK comes in. And grayscale is just whenever you have just the one color, just black. And then Pantone is for spot printing or for screen printing. Like for instance, if some of you have on a t-shirt that has an emblem or something or a logo printed on it, that was done in Pantone colors with screen printing. So RGB. The RGB model goes from 0, which is black, to 255, which is white. And there's 3 different colors that comprise the RGB color. And this is an additive color, and what I mean by that is that if you only have one of them, like the R, like the red, you only have red, then that's one color. You add the other 2 to it, and you end up with white, because the more you add, the whiter it gets, the lighter it gets. So, when you're on screen, you're mixing color. And let me just do something really quick. Let's turn off the lights really quick. That is 0 in RGB. There is no extra color. You can see a few things because I didn't turn everything off, but that is 0. And that is 255. So just to get you kind of familiar with those ranges, because it's not like 0 to 100%. It's 0 to 255. And the 255 comes from the computer stuff, which we're not really going to be concerned with today. But 255 is 100%. If you were to use a prism, you could separate the colors. So remember, it's an additive color. You add more, you get a lighter color. Some of you may have had this when you were in elementary school, the Roy G. Biv, that's hard for me to say. Red, orange, yellow, green, blue, indigo, violet, and that's the spectrum of the rainbow. So that is also RGB. So Roy G. Bliven, RGB. Red, green, blue is so much easier for me to remember. Okay, like I said, if you have all of the colors mixed together, you get lighter. The more colors you have, the lighter it gets because it's an additive color. The rainbow is RGB. And honestly, I'm more comfortable mixing colors in CMYK, and we'll end up talking about that here in a minute. Most of the projects that I do as a professional designer do end up in CMYK or PMS. And occasionally I have to convert those projects into RGB, but generally I am more focused on CMYK. And I want you to know something, whenever you convert CMYK to RGB, it's not nearly as good as doing it vice versa. And I'll explain all that to you in a minute also. Okay, in Photoshop, I want you to know that you're going to be working in RGB. And here's the reason, because you won't be able to get to all the different functions and filters if you have it's in CMYK mode. There's a lot of stuff that you can do in RGB that's just not available in CMYK. So always work in RGB and Photoshop, because those things will be grayed out. Okay, CMYK. Those are the colors of CMYK. C is cyan, which is kind of a teal color really, but it's cyan. And then the real pinkish looking one, that one is magenta. And it's kind of a pinkish purplish color, but that's the color they chose. There's science behind all of this, I promise. And then yellow, and then there's black, okay? Why is it that black is K? That's weird, isn't it? By the way, the colors of pigment are CMYK. So just to let you know, the K in CMYK stands for key, K-E-Y. And the reason for that is whenever people were first using this system in the print shop world, they would have 4 different layers. There would be the cyan, magenta, and yellow, and then the black layer. All the really important information was always on the black layer because if you're going to print in 2 colors or 1 color, generally black is going to be one of those colors. So all the important information about who the job is for, the date, the job number, all of these things are always on that black plate. So it's the key plate. It's the one that's the most important out of all the plates because you have all your information there. So they started calling it the key plate. So you had cyan, magenta, yellow, and then the key plate. But it's black, so it's actually the color black, but it stands for key. Anyway, so I'm going to go on to CMYK now and stop giving you history lessons here, which is the point, but not really the point. Do you remember finger painting when you were in elementary school? That was really fun, right? And you got to mix all those colors on the paper. You had yellow and blue making green and red and yellow making orange. And all the colors together did what? You got a big muddy mess, didn't you? So what that means is it's subtractive color. Remember, RGB was additive color. The more you add, the lighter it gets. In CMYK, it's the opposite. The less you have, the lighter it is. So let's do a little bit of an experiment. Let's just go back to that for right now. What we're going to do is we're going to take cyan, magenta, yellow, and key, black. And we're going to put it on a plate. And we're going to mix colors and see what we get. That was really fun, wasn't it? There's something primal about getting paint all over your fingers. It just kind of takes you back to your childhood. But I wanted to do that so that you would understand the difference between, the major difference between CMYK and RGB is that you add the colors together and you get this dark color. And if you have fewer of them, you subtract them, then you have lighter colors. So, anyway, that illustrates that very well because it has yellow on the top, and whenever the circles all conjoin, you get black. In theory, that's why black is added, because it has a little bit more richness. And to the right over there is actually a separation for that color picture that's to the side of it. And that's the CMYK plates. And whenever you're in printing, you have printing press plates. And that is actually a metal plate. They use aluminum these days. And each color is given a plate. And like this example shows, you have the different colors separated. So, and they're done in a dot pattern so that whenever they all get together, they make a full color photograph. And so now we're going to go on to web safe colors. I know that whenever you get into Dr. Earlbeck's video class and your web classes, that you're going to need to know about safe colors. And it's used for websites, and it's called hex, hexadecimal or base 16. I mean, it's all very, very computery. And the way that they express their color values are completely different than CMYK, which does from 0 to 100, and RGB, which goes from 0 to 255. There is some reasoning for this. I think it's got to do with coding. Don't quote me on that. But pound and then 6 zeros is black, and then pound and 6 Fs are white. So to me, there's no rhyme or reason, but there are plenty of places on the web that will give you the colors that you want. The tech red color in hex is pound CC0000, 4 zeros. I know, I have to do that all day whenever I'm changing things for web or for emails even. Anything that's digital. So let's go on to, and this is why it's important to pay attention to color. I have too many effects in this thing. Okay, so right here we have a big A that's in RGB, and you see it's 000, so that is RGB black. If you convert it, just straight convert it into CMYK, look at what you've got. 75%, 67, 90%. That would drive a printer crazy. You can't do that. Whenever you're doing black for printing, it needs to either be 100% black or a rich black, which is 20% cyan, 20% magenta, 20% yellow, and then 100% black. This would drive a printer crazy. And let me explain why that would drive a printer crazy. Remember, we've got these printing plates. There's a little bit of color on every single one of them. And if you had that 67, 87, 87, 90, whatever it was, on a printing press, chances are it's not going to line up perfectly. Because remember, I told you that all the colors are represented by dots. It's very seldom that, I mean, you do have, of course, in 100% black, you have solids on a printing plate. But if you're doing something that has a gradation or different colors, like it's a shadow or a wrinkle in somebody's shirt or something like that, you have something more like that because it's all represented by dots. The bigger dots, closer together, is more dense. The farther apart they get and the smaller they get, it's a lighter color. So, here is a comic book that I blew up. And you can see all those dots. You can see that they didn't get it all exactly right. That's called, to get everything exactly right is called registration. When it's not registered like that, it's called out of register. So you can see that the red is way out of register. And the dots, they don't line up. I mean, the spectacularness of that is completely gone because it's so out of register. Kind of makes your eyes cross. So if you were to have this A that we looked at to begin with, that was in all of those different colors, when you converted it from black RGB to black CMYK, if it's not in register, all those other colors are going to peek out from the edges, and it's going to make it look fuzzy. It's going to make you think your eyes are crossed. So that is why it's so important to understand when to use the correct colors. There's also another pitfall whenever you're converting from RGB to CMYK. Our screens are made up of light, and everything's bright and very, very clear and all of that stuff on our screens. But whenever you convert it to CMYK, everything goes a little bit muddy because paper is not illuminated. You know, paper has whiteness and there's different brightnesses and all that kind of stuff, but it will never match a screen's brightness. So when you convert something from RGB to CMYK, you sort of get a little bit muddier. It gets a little darker. And you can see on this slide right here, I had a little image that I changed from RGB to CMYK. And it's subtle. It's not like day and night or anything like that, but it's enough to make a designer go crazy, because designers are very into what they want it to look like. And if you convert like this and it really shifts, and some colors shift more than others, especially like blue. Look at the blue. It really has gone crazy. So be aware that that happens. If you're doing something and you know that it's going to be in CMYK, be aware that it is not going to be as bright when you get it to the printing press. Pantone matching system. I would say that this is probably the #1 thing that confuses a new designer, because, you know, it looks right on my screen, but it's not. If you're going to do a t-shirt and you send them a file that is in RGB, they are either going to charge you a lot of money to convert it, or they're going to send it back to you. One of the two. There's no in between here. So in Pantone matching, the key word here is matching. This started in 1963. It was, before that, the colors were just all over the place. You've been to a paint store, right? And you can see how many chips there are and how many color names there are. I mean, it's unbelievable how many different colors can be named for the same lime green. It's just unbelievable. So to eliminate this problem in the printing industry, the Pantone matching system was developed. And the idea of it is each number is assigned a color. So the idea of that is, if you go to a printing shop in New York City and say, I want this printed in PMS 485, and then you go to a print shop in Lubbock, Texas, and say, I want this printed in 485, the idea is that both of them are going to match. And it does mostly. You know, there's differences, but not enough for a layman to understand or to even see. Each color is assigned a number. And 485, just by the way, is the color that we always consider Texas Tech red. Most printers around here will kind of bump up the color so it's a little brighter and not so maroon or not so orange, but the official color you use whenever you're using Pantone matching system, PMS, is 485. Each color, you know, people that run printing shops, you know, there's thousands of these colors, and they don't keep thousands of colors on their shelf. What they really have is more like a recipe. You know, in the paint section of Lowe's or something, you go in and you say, I want this color. They don't say, okay, well, here you go, here's a bucket of it already mixed up. No, they take their little book and they see what the recipe is, and it uses the standard basic colors, they mix it up, and it matches. And that's the same thing with PMS. So don't think that the printer's got a back room that's got thousands and thousands of inks in it, because they may have a lot of inks, but they don't have every PMS color already mixed up. What they have is a little book like this. And it's hard to see on here, but you can actually see the recipe. It tells you what parts, and it's not like, oh, a cup of this and a pinch of that. It's actually weight, you know, parts of it, like ratios, like 1 to 2, 3 to 4, you know, those sort of things. Remember math? I mean, I don't remember math, but ratios are very important when you're mixing colors. And there's 1,341 solid colors. Now, that is not counting the metallic tones. That's not counting there's others. There's lots and lots of others. And by the way, all of your programs, Illustrator, InDesign, Photoshop, they all have these books, these color palettes built into your software. So if you want to use PMS 485 on something, all you have to do is go to that palette and load that color. You don't have to go searching for it somewhere. It's there for you. When you use Pantone colors, generally it's always Pantone is used for only print design. And you use it for spot colors. Let's say you wanted to print something that was in black and red. What you would be using is, you would be using black and Pantone 485, or a different red, but at Texas Tech, it's only Tech Red. So spot color would be red, And what a spot color means is, remember those plates that have the cyan, magenta, yellow, and black? Well, this would be like another plate, a fifth plate, 485. Spot color separates completely out of the CMYK spectrum. They don't mix in with the other colors. They are their own entity. And let's see. It's mainly used for like branding, logo design, and that sort of thing. And so it doesn't divide itself. It's strictly a standalone color. So we're going to be doing a t-shirt later in the season, later in the semester. And that's when we're going to start using Pantone colors. And we'll also tour a place that they do screen printing of t-shirts, and you'll kind of more understand why it's so important. But for today, that's it. So if you have any questions, come up and see me or email me, and I'll see you next time.